Okay, here we're dealing with some examples of questions which talk about parallel and perpendicular slopes. Parallel slopes being equal to each other and perpendicular being the negative flip or negative reciprocal, meaning whatever this is, let's say 2 over 3, it's going to now flip to 3 over 2. So if it says L1, line 1 has a slope of 1, which of the following points would be parallel? Well, we know the slopes are going to be the same. So what I need to do is find the slopes of each of these lines, negative 3, minus or minus 4. Here I'm doing my y2. All these in column are going to be x1, y1, x2, y2. And then I have 5 minus 12. This is adding 1 over negative 7, okay, which means my slope is 1 over 7. I'm looking for just something with a slope of 1. So we can look at B, 6 minus 5 with a negative 5 minus 0. That gives me a 1 over negative 5. That's not it. C, negative 5 minus a minus 6. Over 5 minus 6, which gives me a 1 over negative 1. I think I just want a positive 1 here. Let's look at what answer choice D is going to do here. 6 minus 5 with a negative 5 minus a minus 6. I end up with 1 over, this is adding. Negative 5 plus 6 is 1. Here's my 1 over 1. And this would be my answer here, okay? Because basically what I did was, I understand that L1 has a slope of 1 or 1 over 1. So I used my slope formula to find the matching slope of here, D. Okay, if it were perpendicular, I would have just looked for something that's negative 1 over 1 or anything just negative. So actually this here would be an example of a perpendicular slope if that's what we're looking at. Here the question's asking, okay, we're talking about perpendicular. They have a slope of 2 over 3. So the first thing I want to say, okay, if the slope is 2 over 3, a perpendicular slope is going to be negative 3 over 2. And they're giving me an x1, y1, x2, y2. So they're saying y minus a minus 5. Right? So I'm just plugging in my y here. And y minus 3. So, and if I would just want to kind of work with the bottom here, 1 minus 3 is going to give me a negative 2. Right, now remember, a negative 3 over 2 is almost the same as a negative 3 over 2. So I have my negative sign. So what do I want on the top? I want this, in order to be a perpendicular slope, I want this number to be 3. I want a positive 3 here. So basically I could say, well, this is y, technically this is y plus 5, right, the negative negative. I want it to be equal to 3. And in order to get a 3 on top, subtract 5 both sides, y needs to be equal to negative 2. Now, that means basically here, my y would have been negative 2. And if I plug that in, negative 2 minus a minus 5, if I'm checking my work, y minus 3, this turns into a positive. Negative 2 plus 5 is 3. 1 minus 3 is negative 2. And I have that perpendicular slope I wanted, which I got from, don't forget, I got from the 2 over 3, basically doing a negative flip or a negative reciprocal. Sometimes what you'll do in some problems is you will evaluate what they give you as far as slope. So in line 1, I have a slope of negative 1 minus a minus 3 and a 9 minus 5. I have a negative 1 plus 3 over a 9 minus 5. I have a 2 over 4 or 1/2. This is my slope for line 1. For line 2, I have a slope of 0 minus a minus 4 over a negative 5 minus a minus 7, which gives me a 0 plus 4 over a negative 5 plus 7, which gives me a 4 over a 2. 4 over 2 is 2. Now, this is positive. The mistake students will make, oh, it's flipped, that's perpendicular. Actually, it's flipped, but the sign hasn't changed. So, and it's not the same. So we would actually say this is neither perpendicular nor parallel. If these slopes had been, let's say, what would be an example of parallel? 1/2 and 1/2, we would say they're parallel. If this slope was 1/2 and the other slope was -2 or -2 over 1, then we would have said they're perpendicular. Sometimes you have to be careful. If they give you the same slope and then you plug L1 and L2 into your y minus y1 equals mx minus x1, and you end up with the same exact, let's say you ended up both lines for L1, y is equal to 1/2 x with the same slope and same y-intercept. So same y-intercept. So you plug both these slopes in, okay, and you end up with the same slope. This would actually be an example of the same line if the slope and y-intercept were the same. Another thing you could do with both these lines too is actually go to the -1 and the 9, go to the 5 and the -3, and you could plot these points and use a graph, the 0 and the -5 and the -7 and the 4. -7 would be over here, -4, right? And you can see like both these lines, yeah, they intersect, but they're not at a right angle, so they're not perpendicular. So graphing is also a great tool for using this type of question, and you can use decimals if you want for that type of question. They may just give you a question where they ask you to find a perpendicular line to a set of coordinates. All that is just, again, using your y2 minus y1 slope formula. 7 plus 11, 5 plus 8, 18 over 13, and it's saying perpendicular, so I want to flip and change the sign. They're asking for, do you understand, okay, is this we'll call it a negative flip, negative reciprocal. They may ask you when it's parallel, so basically you're just finding the slope of this line. I mean, ultimately, if it's going to be the same, all you need to do is find the slope of the line. -8 plus 3. This is good practice with finding slope. -5 over 1, which is also -5. And then they may ask you, okay, if a line has a slope of -1 over 7, which line of the following will be perpendicular to L1? So it's saying that the slope is -1 over 7. It's asking for perpendicular. So basically you have to find which one of these slopes, A, B, C, or D, when you do your y2 minus y1, x2 minus x1, and you plug all these answer choices in, you have to find the one that's going to give you a 7 over 1. Now, one of these answer choices may give you an answer like 14 over 2. Or maybe they give you, 21 over 7? No, 21 over 3. And these also reduce to 7 over 1. So if one of those slopes gives you that 7 over 1, that would be the slope that's perpendicular.